My name's Stephen Lee. I'm a professor of biophysical chemistry and I work at the University of Cambridge. I don't think I've ever met a child that's not curious about the world. I don't think, when you're a kid you ask why is the sky blue and why the grass is green, and I think at some point people that don't become scientists kind of grow out of that a little bit, but I think scientists are just children that don't grow up. So I'm still kind of curious, just asking the why questions that annoyed my mother at 5 years old. I'm just asking the same question now at 40. So I think it's just a kind of innate curiosity of the world that just is kind of childlike, I think. So we build microscopes in our lab, and we kind of take them apart and see how things are working. And I think, again, it's from a young age, I was always kind of interested in how things worked and how they were made. I remember as a kid, I put a jam sandwich in a VCR, and it went in and obviously ruined it. And then my mum came in and she was super angry and she said, what are you doing? Why did you do that, Steve? And I said, well, I wanted to see how it worked. And it was a good answer because she couldn't really be angry at me at that point because, trying to understand how it worked was quite important. And my dad, we took it a bit to bits and we took the jam sandwich out and the VCR never worked again, but it was fun taking it apart and learning how it worked. So I suppose that's what kind of interests me in how things work, and we continue to do the same thing, but rather than looking at jam sandwiches and VCRs, we look at microscopes and look at cells and how they interact in your body. So I suppose my favorite thing about being a scientist is the opportunity to kind of collaborate with incredible people. So we're a really interdisciplinary lab, which means that people from our lab come from all different scientific backgrounds. We have people that are electrical engineers and biologists and chemists and physicists and kind of software developers. And you really get to work with just like some incredible people, and you get to work on problems that hopefully will try and make the world a little bit better. Will leave the world a little bit better than you found it, and I suppose that's what's the best part, is kind of collaborating with really exciting, talented people. I think as a scientist, you've got to be interested in the big questions, right? So people quite often say the so what questions. And I would argue there's basically kind of three big so what questions. And so that's kind of energy, climate, and medicine or health and biology. And I suppose what we've decided to do in our lab is go down that kind of health approach. So we're trying in the lab at the moment to try and develop new methods to try and understand problems that directly impact human health. So we're working, for instance, in Parkinson's disease. So we're trying to understand how proteins misfold in that disease for people that are unfortunate enough to get it, and how we can basically, how basic understanding of the biology might lead to translational breakthroughs. And that to me is super exciting and a reason to get out of bed in the morning. I think we do have superpowers, and I think if you imagine the Avengers or something, the one that's most influential to me are the people that, the Tony Starks and the Bruce Banners, right? They're the people that kind of think in a different way, and that's the real superpower. So I think we do have superpowers. We just we just can't jump buildings and go faster than the speeding bullet. So I think longer term, where I think I'm excited scientifically about what's going to become next, is we're at this real kind of inflection point, I think, with advanced computational algorithms evaluating larger and larger data sets. I think if you were to jump forward 25 years into the future and look back, I think there's going to be two kind of pillars. One of those will be access to more personalized medicine, so how my body's different to your body, and then that will be evaluated by these algorithms, these AI, machine learning, those kind of things. And I think that kind of first problem, there's a lot of people interested in the latter, but there's actually very few people that are actually trying to invent the infrastructure to be able to achieve those things. So actually I'm excited in getting access to larger and larger data sets and trying to kind of understand them in new ways. And I think that's really where the future's going to be scientifically.